Okay, so 4.3 to 4.4 word problems. I'm going to read the first one with you, but the rest of them I'm not going to read. So you pause the video, read them, and then watch the solution. It's a lot easier the first time around to be able to pause it, take notes at your own pace. So please, I encourage you to take advantage of this opportunity to see the lesson in a manner that makes it easy for you. So the word problems. So all of these geometry problems, I encourage you to draw a diagram and know how to solve these quadratics using the easiest methods. So the first one, you have a rectangular vegetable garden in your backyard that measures 15 by 10. So right now we know we have a garden that's 15 by 10. So that's the dimensions here, 15 by 10. It says you want to double the area of the garden by adding the same distance and length to the length and width of the garden. So what we're going to do is extend this side by so much and extend this side by so much. And what we want to do is double the area. So the amount we add to each side will be the same. So what do we call the distance we added here? We're going to say x. We're going to add x here. So right now, if you go back to the original rectangle, what is the area of this? Well, 15 times 10, right, will give you 150. Okay, so if we want to double that, what do we want the area to be? 300. So if we take the new length and the new width to find the area, we know the new length times the new width should equal double the area. Well, if the area is 150, when we double that, it's 300. Now the new length, what do we do with the 15 and x? We're going to add them, x plus 15. The new width, what are we going to do with these? You're going to add them, x plus 10. When we multiply that, we should get 300. Some of you might be able to logically figure this out. Some of us, we might have to solve the quadratic. So when I distribute here, I get x squared plus 10x plus 15x plus 150 equals 300. I'm going to do two things at this step. One, I'm going to set it equal to 0 by subtracting 300, but I'm also going to combine these like terms. So I end up with x squared plus 25x minus 150 equals 0. Now I can go ahead and solve this quadratic by factoring. So to factor this, we have to figure out what multiplies to give us negative 150 and adds up to 0. Well, that factors out to be x plus 30 and x minus 5. Well, when I set these equal to 0 and solve, I get x equals negative 30, x equals positive 5. Remember, x represents how much we're extending it by. Am I going to subtract 30 from each side? No. So the only answer that makes sense is 5. So when we look at the new dimensions, right, the length will now be that 5 plus the original 15, which is 20, and the width would be 5 plus 10, which is 15. So the new dimensions are 20 by 15. And if you think about it, when you multiply those together, do you get an area of 300? Yes. Okay. So next one says you have a rectangular quilt that is 5 feet by 4 feet. So you have 5 feet by 4 feet. And you have 10 square feet, that should be square feet, remaining to add to the border. So they want you to create this border around that's equal on both sides. Okay? What should the width, we want to know the width of this border. Well, if you look, we're going to say the green rectangle is the quilt with the border. So we're going to say the big rectangle, which is the green one. Now, to get this area here, if I wanted to say this is the border, this yellow area, the area of that, right, is the big rectangle minus the small rectangle. And that'll leave me with the yellow part I shaded in. So minus the small rectangle, or the original one, should equal how many square feet I have for the border. So now if you think about it, I'm extending this x units here, and I'm extending it x units here. I'm extending it x units here and here. So now the new length of this side is 5 plus x, which is going to give me 5 plus 2x. So the area of the big one, we're going to take the 2, we'll say 2x plus 5 times this side is going to have a length of 4 plus 2x. And the reason is you have this 4, but then you're extending it here x and here x. So now we're going to multiply that by 2x plus 4. But then the area of the inside one would be 5 times 4, which is 20. So that's what we're going to subtract here. So when I take the area of the big and subtract the area of the small, it should give you 10 square feet of border. Now when I solve this, I'm going to simplify the left side. This is something you should be able to do. Distribute and then subtract the 20. This becomes 4x squared plus 18x plus 20. That's what you get when you multiply the binomials. Subtract 20 equals 10. Well, when I set this equal to 0 and combine these terms, I get 4x squared plus 18x. 20 minus 20 is 0. And then when I subtract the 10, I get minus 10 equals 0. Now, when I factor this, first I'm going to start with the GCF. So I get 2 times 2x squared plus 9x minus 5. But now I'm only going to focus on factoring this. When I factor this, what numbers multiply to give me 2x squared? So 2x and x. And how about negative 5? We would say 5 down here, negative 1 here, right? Does that give us, that gives us negative x, that gives us 10x. Does that add up to 9x? Yes. So this factors out to be 2x minus 1, x plus 5 equals 0. Well, right away, when I set these equal to 0, x is equal to 1/2 here, x is equal to negative 5 here. Which border makes sense? The 1/2. Excuse me. So the width of the border would be 1/2 on each side, all the way around. So the third one, there's a rectangular park in town that's 60 by 40. So you have 60 by 40. And right away, you know the area of that is going to be 2,400, right? 60 times 40. I want to double the area, right? By extending the same distance on each side. So I extend this, x units, x units. So now, what is the new length here? 60 plus x, or x plus 60? Here we'll say x plus 40. So again, just like the first example, the new length is x plus 60. The new width is x plus 40. When I multiply these together, it should equal double the area, which would be 4,800. Now, when I go to solve this, I multiply x squared plus 100x plus 2,400 equals 4,800. Set it equal to 0 by subtracting 4,800. X squared plus 100x minus 2,400 is equal to 0. This will factor out to x plus 120 times x minus 20. You know right away this is going to give you negative 120. That makes no sense. This gives you 20. That is a possible length you can add. So your new dimensions would be 60 plus 20 is 80 by 40 plus 20, 60. If I multiply that together, I get 4,800. Next one, your flower bed is 22 by 15. Okay, so we have the 22 by 15 flower bed. You want to put a uniform size border on each side, meaning we have this border here. So that's the area we're gonna be looking for. Okay, so right now it says you want to put a uniform size border around it. You have 120 square feet of stone. For this yellow area, you have 120 square feet to fill. Well, I know I'm extending these two sides by x, and I know I'm extending this by x and x also. So the length of this side would be 15 plus x, which is 2x. This would be 22 plus x, which is 2x. So now the yellow area, we would take the area of the big rectangle. So the area of that is, and I'm going to just write it in order that makes sense, 2x plus 15 times 2x plus 22, right? But then when I subtract the area of the inside, the area of that inside is 22 times 15 is 330. So we subtract that 330, and that should equal the square footage of stone I have, which is 120. Now when I distribute, when I FOIL this out, set it equal to 0, you should end up with 4x squared plus 74x minus 120 equals 0. Factoring this, you would get 2x minus 3 times x plus 20 equals 0. You know this is going to give you negative 20. That answer makes no sense. This gives you 3/2, which is 1.5. So you're going to extend each side, or the width of the border around, right, would be 1.5 feet around the whole thing. All right. Now 5 and 6 are very similar to these, right? I'm just going to give you the answers, right? You would add 2 inches, right, for this one, and your new dimensions would be 6 by 8. And then the last one, number 6, right, the border would be 1/2 foot wide around the whole thing. Okay, so do me a favor and work on the 4.3 to 4.4 word problems, and we're going to do a second day tomorrow.